In this video, we're given a graph that describes the displacement of a car. So the car moves in two different chunks. It moves 3 miles to the east, and then it moves off at this angle to the northeast. And each of those chunks is a displacement vector, and they naturally add head to tail. And what I want in part A is the total displacement vector. And that's the vector that points from the original position of the car to the final position. In part B, I want the component form of that total displacement vector. So really I just have to count spaces here, but here's the vector components. The car moved a total of 6 miles to the east, and it moved a total of 3 miles to the north. I'm just counting spaces on the grid here. And so the unit vector notation for that displacement vector D is 6 miles I hat plus 3 miles J hat. In part C, we're asked to get the total displacement in polar form. So I need a magnitude and an angle. And I want to state the angle with respect to the x-axis. In other words, I'm labeling it right here. And to get the magnitude of the displacement, I just use the Pythagorean theorem. I take the square root of the sum of the squares of the legs. And we'll just go ahead and use a decimal approximation. And this gives me 6.71 miles. So that means the car ended up 6.71 miles from the origin. Note that the total distance traveled by the car, that's still 9 miles. But what the magnitude of the displacement means is how far is it from where it began, and that's 6.71. The angle is given by an inverse tangent. The angle whose tangent is 3/6, and I get 26.6 degrees for that. So we could say that the displacement for the car is 6.71 miles, 26.6 degrees north of east. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.